Kristen Ashison here, and we're talking about quasi-experimental methods. Now, as you remember, we had to scrap a lot of this chapter to accommodate our inclement weather days. So we are just going to cover the basics of quasi-experimental methods and the distinctions between quasi-experimental methods, true experiments, and non-experimental designs. So as we've discussed previously in this class, true experiments involve a manipulated independent variable. So remember, the researchers are doing something, they're manipulating that independent variable, and then they're measuring those effects on the dependent variable. Again, this will have treatment or control conditions, and these groups are assigned by random assignment. Everybody has an equal opportunity of either being in the treatment group or the control condition. We're not dealing with pre-existing groups. We're not dealing with subject variables. We really are dealing with true random assignment to the various conditions. And again, the researchers are manipulating that independent variable to, this is how we determine cause and effect. When we talked about experimental designs that determine cause and effect, what we're talking about is true experiments. These also have a high degree of control. As we've discussed again in detail, all the various things we discussed at the beginning of class that we do to control for extraneous variables and why we do that. These are all those characteristics of true experimental designs. Again, the major one is this random assignment to conditions. Because of this high level of control and because of random assignment and because we're manipulating the independent variable and holding all of their conditions constant, there's no ambiguity on the outcome of the independent variable on the dependent variable. If we have a change between the two groups on the dependent variable, we can say it's due to the independent variable in a true experiment. And this gives us a lot of internal validity. And so again, the previous examples that we've discussed are true experiments when we really are manipulating the independent variable. And if you think about true experiments, quasi-experiments, and non-experimental designs kind of on a spectrum, we see that true experiments are the most highly controlled. So if you were to draw a line and you put true experimental methods at one side, non-experimental methods at the other side, in the middle you put quasi-experimental methods, and on the side with true experiments, this is the side that has high control. And we do this by holding conditions constant. And the primary way we do this is by random assignment to conditions. So you can't randomly assign subject variables. You can't randomly assign someone to be male or female, schizophrenic or not schizophrenic. You just are. So those subject variables would not be true experiments because we are not manipulating. Everyone does not have an equal chance of being assigned to the conditions. So true experiments are the most highly controlled, and because of that control and because of random assignment, again, we're able to make those cause and effect judgments about the independent variable acting on the dependent variable. An example of this is any manipulated independent variable. And again, it's going to have random assignment and high degrees of control. These are not subject variables. This is not talking about age. This is not talking about sex. This is not talking about race. This is talking about I take all of you in the class and we do our bag of random assignment, and you equally have chances to be in the peanut group, the M&M group, the plain M&M group, or the peanut butter M&M group. That was random assignment. Now, granted, that didn't have a lot of control, but in a true experiment, that kind of random assignment combined with high control and holding all those conditions constant is when we have those true experiments. Quasi-experiments are not quite an experiment. Again, that's that middle ground on that spectrum. If you're thinking about that spectrum, that's in between true experiments and non-experimental designs. And quasi means that it's resembling an experiment. We're doing everything we can to approximate a true experiment, but there's something that's keeping us from hitting that high level of control. We really use these when true experiments aren't possible. Again, true experiments are going to be our gold standard, are going to be what we're trying to strive for, but there's some things that you can't do that with. So if you're looking at those kinds of subject variables, if you're looking at gender, if you're looking at age, if you want to compare kindergartners, first graders, and second graders, then you take first graders, kindergartners, and second graders and you compare them in a quasi-experimental design, because I can't randomly assign those children to either be kindergarten, first grade, or second grade. They just are. That's just a subject variable. We've lost some of that element of control. And when we lose that high degree of control from true experiments, we're into that quasi-experimental design. This is, again, doing everything else that we can to approximate a true experiment. We're going to still hold all the conditions constant. We still may be manipulating another variable in terms of a factorial design. But we're missing one piece that's making this highly controlled, where we can say, make these judgments, true judgments, of really valid judgments about cause and effect. And this is going to create a situation where researchers are going to have to get other information, other evidence to really eliminate these threats to internal validity. So they may do lots of different kinds of studies. They may do some cross-sectionally, some longitudinally, to kind of look at some of these issues. And again, this is going to be that kind of middle ground on the spectrum. We're doing everything that we can to really make it look like a true experiment. But because of that subject variable, we no longer have a true experiment. We have a quasi-experiment. So an example of this would be, again, any kind of study where we have a subject variable. And because of that subject variable, random assignment's not possible. And so we're into that quasi-experimental design. Again, if I was comparing psychology majors and chemistry majors, that's a subject variable. You just are psychology or you just are chemistry. You've made those decisions. I can't randomly assign you to be a chemistry major or to be a psychology major. You have chosen that, and that is a variable based on you, the subject. And so because that random assignment is not possible, we are into that quasi-experimental kind of design. Again, in that spectrum, it's in the middle. And that's because of that control, that lack of, it doesn't have those high gold standard of control that we see in true experimental designs. Non-experimental designs are going to be the kind of the furthest on this spectrum. So we have little or no attempt to control for the confounds or threats. Whereas again, in quasi-experiments, we're doing everything that we can to make it like a true experiment, but there's some degree lacking. So non-experimental designs are going to be all the way at the other end. We have little or no attempt for these kinds of controls. A lot of times non-experimental designs are information seeking. So survey designs are usually qualified there because we're not really conducting a true experiment. We're just kind of information seeking. Other kinds of non-experimental designs, if we don't have a comparison group, if we're just studying one group and we don't have a comparison group, that can do that for to us. Again, if you're thinking about this spectrum between non-experimental designs this is where we're talking about the little or no control on that spectrum, whereas true experiments have really high degrees of control, and quasi-experiments are again in the middle on that control. Using pre-existing groups that are based on subject variables means that people are being automatically assigned to groups. We no longer have that random assignment. So if we're asking, are males and females different on some measure, this is a quasi-experimental design. If we're really using these pre-existing groups and we have no other kinds of controls, we really get into this non-experimental design when we have there's so many other factors involved here that we have no kinds of control. A lot of times we'll see things like this, if males and females are different. Sometimes that subject variable will really be used as in a factorial design, because in a factorial design, we can have it be another factor, and then still have a manipulated experimental design, because there's so much that's different between males and females. In my developmental classes, we spend, a lot of time talking about these kinds of actual differences and these kinds of learned differences. There's so many different variables going on here that we wouldn't be able to say that just being male is what caused any difference on the dependent variable, because there's so much else going on in what it means to be male and in what it means to be female in our culture. So again, this is classified as non-experimental because there's very little control. It's again these subject variables. A lot of times, again, we will do these things in factorial designs, so that we can have really controlled conditions for that other factor, and we can do those kind of manipulated things. These are often grouped with correlational research, because it has no ability to make judgments on cause and effect. Non-experimental research does. Lacking that level of control puts us in that just kind of information seeking. This is, there may be a relationship there, other variables may be at play. But again, we're not able to make any judgments or even speculations really as to cause and effect, because there are so many other variables at play. Again, as I mentioned in factorial designs, a lot of times we'll combine these sorts of things. We'll combine strategies that are both experimental, quasi-experimental, and non-experimental. The easiest way to do that is have one of your factors be a manipulated variable and have another factor be a subject variable. Have them, again, look at these things separately. As I mentioned, you may be looking at males versus females in addition to a manipulated factor, something that you as the researcher are manipulating and changing to see how that affects the dependent variable. An example of this is our picture book example that we've been talking about. This is a factorial design that combined both experimental conditions and non-experimental conditions, because we have this subject variable. So again, we have a version of the picture book. Barbie, M are neutral. We had random assignment to that condition, to those three conditions. We had the kindergartners, all of them had an equal chance of being in one of those three conditions. Because of that, that was an experimental factor. Whereas again, kindergarten, first grade, and second grade is a subject factor. So that is again an example of a non-experimental factor. Another one from your book, we're looking at researchers manipulating whether participants performed in front of an audience. That's going to be our experimental factor. Audience is going to be our experimental factor. We can randomly assign participants to either be in the audience group or the non-audience group. In this example, their non-experimental factor is high self-esteem or low self-esteem. People either have high self-esteem or they have low self-esteem. You can't, in this example, there wasn't manipulated. That's just a subject variable of who they were. So again, this would be a design that employed both a non-experimental factor and an experimental factor. And a lot of times that's what we'll see, because it allows us to still have internal validity for one factor and make cause and effect judgments for one factor, but look at the other factor and look at the other factor in a relationship with the first, which gives us a lot more information than just looking at high self-esteem versus low self-esteem alone. Because then we're both able to make judgments about the main effect, if any, of high self-esteem and low self-esteem. But we can also see how that subject variable of self-esteem, if at all, relates to the manipulated variable of audience or no audience. And as you can see here, it looks like there is an interaction. These lines are not parallel. So we do see when the low self-esteem participants are put in front of an audience, they make more mean errors than the high self-esteem or when the low self-esteem is not in front of an audience. So again, it does look like we do have an interaction here. So by combining both this experimental factor and this non-experimental factor, we were able to find out more information, but still have internal validity for our main effective audience as a manipulated value. So that kind of wraps it up. Again, what I really want you to understand is the distinction between non-experimental designs, quasi-experimental designs, and true experiments. Again, you are responsible for the entirety of chapter 10, but that's the important information that I want you to have and the distinction that I want you to be able to make for this course and for research designs as a whole.